All right, let's talk about another gate called the NAND gate, or the negated and, or I like to say not and. Not in programming is basically an inversion of a condition. So NAND gate, it is basically a gate that produces the opposite output for the same inputs as a NAND gate. All right, so let's take a look at the NAND gate. The symbol for it looks very, very similar to an AND gate. The only difference is this little circle here, which tells us that the output of the gate is inverted from the AND gate that it's built on top of. Okay, so remember, in an AND gate, if both of these are on, then the output is on. But with a NAND gate, because of this little circle, when both of these are on, the output is off. And that inverted logic carries through the entire truth table. So let's look at the entire truth table, right? So we can see that if both, in the NAND gate, if both inputs are off, then the output is on. If one or the other input is on, okay, individually, then the output is on. And if both inputs are on, then the output is off. So this column is completely inverted from what we would see with an AND gate. If this little circle wasn't here, if both of these were off, then this would be off. If one of these, but not the other, was on, then these would be off. And if both of these were on, this would be on. Okay, so it's completely inverted from an AND gate. And the drawing, you can see that the NAND gate is built on top of the AND gate. It's just a little addition right here. So when we move that to a circuit, you'll see that the actual circuitry for a NAND gate can include the circuitry for an AND gate. It will. Just to kind of illustrate that, let me disconnect these two circuits. So I'm going to just pull this yellow wire here, and I'm going to put back our an LED. So I have a blue LED here, and I have the long leg. I'm going to put that in the positive side of the bus, and I'm going to connect it to the output of our, or basically it's the emitter of our transistor. Okay, I just bumped that guy there. Now this circuit here right now is completely independent, so just ignore this guy. All right, now we basically here, if we were to look here, we have an AND gate. So we just have an AND gate. And so, for example, if I push the one button, nothing happens. If I push the other button, nothing happens. But if I push both buttons, then boom, that's the AND gate, right? And so what we want to do is we want to invert that. Well, we know that one of the states is when both of our, let's get this guy here, get the good connection. We know that when both of these inputs are off, we want to make sure this guy is on. Okay, so right now in this state, this is good, but if I push both of these here, nothing happens over here because this circuit here is not connected to this circuit. So what we're going to do is we're going to take this transistor, when this transistor gets turned on by this button, and this transistor is turned on by this button, remember, then right now the circuit completes and goes to ground here. Well, what we're going to do is we're going to create a path to ground when both of these are on, and we're going to put this in the same row as is feeding power to this LED, this output essentially. And so now when both of these are on, pushed down, you can see the AND gate operating with the blue LED, right? And you can see the NAND, the little NAND addition that we have, turning off. And so for now, let's just keep that blue LED in there, even though right now it's an additional output that we wouldn't normally have on the gate. But here you can see if I push one of these, nothing happens. This stays on, right? Just following our truth table that when only one is on, but not the other, this is on. And here you can see that the NAND gate is doing the opposite. So here, now we see it's doing the opposite, still doing the opposite when just the other one is on. And if both of these go on, then our AND gate would go high, but our NAND gate goes low. So just to make this operate with two inputs and one output, we'll pull this output out because that's not a part of this gate. And now you can see, this operates exactly as we would expect. And that's called a NAND gate. And the reason it works from from the electronics perspective is just that, remember, when these two transistors turn on, they're creating that path, that basically a short path to ground for the current.